Let's now take a look at some exam questions regarding geometric progressions. It's a little bit difficult to find exam questions that are focused only on geometric progressions. Usually, they are combined with at least one sub-question that regards arithmetic progressions. So that's basically what you're going to find here. The first one is from this October-November 2009 paper 12, and the question is this one, question 3. A progression has a second term of 96 and a fourth term of 54. So U2 equals to 96, U4 equals to 54. Find the first term, so you have to find A of the progression in each of the following cases. If the progression is arithmetic, or if the progression is geometric with a positive common ratio. Okay, so you are not given the first term, you are not given consecutive terms, but there is a term missing between one and the other. So in these cases, how do you solve these questions? You just set up simultaneous equations. Okay, because that you know that U4 minus the U3 that you don't have is equal to the common ratio. Then that U3 minus the U2 that you do have equals to the common ratio. And then the U2 minus the term that you want, the first term, A, also equals to the common ratio. So basically what you have 3 equations and 3 unknowns, meaning that you are going to be able to find them all, and including the only one that is actually being asked. Okay, so just substitute the values. In this case, I used elimination. I subtracted the first one to the second one. So 96 minus 54 equals, well, the U3 is eliminated, and you get minus 2D. So D equals minus 21. And now that you know the value of D, just plug in on the third equation, and you get the value that you want, A. Simple enough if you know what to do. Okay? What if it is a geometric progression with a positive common ratio? You do something very simple. That's very similar, but now using ratios instead of common differences. You know that U4 minus the U3 that you don't know equals the U3 over the U2 that you do know, which equals the U2 over the A that you want, and that is the common ratio. So basically you have also 3 equations and 3 unknowns, meaning that you are completely sure that you are able to solve it. So using this, I just used a crisscross, and I have U3 squared equals to 1184. Then I plug in the square root of this, that's the value of U3 over here. I know U2, and that's going to be my common ratio. And now that I know my common ratio, I plug it over there, and I'll do the appropriate algebra, and I know the value of A. Okay, put it in a calculator, and there it is. Okay, so if you know what to do, these questions can be done in the time it takes to write them down in a paper. So, and you'll have, where is it? 6 points. Let's look at the next one. This is a June 2009. So paper 1, and it's question 7. Find the sum to infinity of the geometric progression with first 3 terms 0.5, 0.5 cubed, and 0.5 to the power of 3, of 5, sorry. And then find the first 2 terms in an arithmetic progression. Sorry, the first 2 terms in an arithmetic progression are 5 and 9. The last term in the progression is the only one. Okay, I'll look at this after solving this one. All right, so you know your A. You can get very easily the common ratio, and you need to find the sum to infinity. All right, so let's go there. This is what you have. The common ratio is going to be either 1 divided by the previous one. So it's 0.5 squared. This is obviously going to be a value that is smaller than 1. All right, so you can actually calculate a sum to infinity is going to be convergent, this sequence leading to an actual number. So just apply the formula. You know A, you know R, and there you have it. It's 2/3. This converges to 2/3. Then let me look at the second question. It says, sorry, it's here. It says the first two terms in an arithmetic progression are 5 and 9. So you have A and you have the second term that allows you to calculate directly D, the common difference. The last term in the progression is the only term which is greater than 200. So you know that L is bigger than 200, and it's the first one. Find the sum of all terms in the progression. Okay, so in order for you to find the sum of all terms, you need to know first the number of terms. So you have to use this inequality over here. You know that UN is bigger than 200, and the first value of n in which this happens is the number of terms that you have to plug in over here. Okay, so just use the formula. You know A, you know D, all right? D is basically 4, okay? And just solve this inequality. So you know that n must be bigger than 49.75, so obviously n is 50. And now that you know the value of n, just use the formula for the sum of the first 50 terms. All right, you know everything in a formula, and this yields this value over here. Let's look at the last one. Last one regards a real-life situation, and it says, a television quiz show takes place every day. On day 1, the prize money is $1,000. If this is not won, the prize money is increased for day 2. The prize money is increased in a similar way every day until it is won. The television company considered the following two different models for increasing the prize money. In Model 1, they increase the prize money by $1,000 each day. In Model 2, they increase the prize money by 10% each day. Okay, so the first one is obviously an arithmetic progression. The second one is a geometric progression. On each day that the prize money is not won, the television company makes a donation to charity. The amount donated is 5% of the value of the prize on that day. After 40 days, the prize money has still not been won. Calculate the total amount donated to charity. If Model 1 is used, that's question 1. And if Model 2 is used, that's question 2. Okay, this sounds too complicated, so it's important that you are able to interpret this in English and break it down and translate it into math. All right, so we already established that you have two different situations or two different models, one of which, the first one, deals with arithmetic progressions, and the second one deals with geometric progressions. Your A, your first term, is obviously 1,000 for all of them until this point, okay? This is going to be 1,000 is also going to be your common difference if you use Model 1. And if you use Model 2, the common ratio is going to be, if it is 10%, is 0.1. Okay, sorry, the price is an increase in price money, not 0.1. Okay, it's going to be 1.1. All right, it's going to be an increase. So you have to add these 10% to the value that you had before. So that's 1.1. Important for you to notice. Important for you to notice also that what you are being asked is not the total prize money, is the one that is given to charity. All right, calculate the total amount donated to charity. And how much is that? This is 5% of that. Okay, so pay attention to this. You are not calculating the total price that is being accumulated. You are calculating the total price, the total value that was accumulated to be given to charity, which is 5% of the total. All right, what does this mean? Let's look at the first one, the arithmetic progression, the Model 1 first, okay? You know that n is 40. You are calculating the whole thing after 40 days, all right? If you apply this formula, the formula for the nth term of an arithmetic progression, this is it for the prize money, not what you want. You want the part that is donated, which is 5%. So you have to do 5% of this. And this is the thing that you're going to work with. 5% of 1,000, that's 50. 5% of 1,000, the common difference is also 50. So this is the actual nth term that matters to you. So you can work with this. So the sum of the first 40 terms is going to be given by the usual formula, in which A is not 1,000 but 50. all right? And D is not 1,000 but 50 as well. So just applying the formula, you can very easily get the value that has been accumulated to charity, which is $41,000 using Model 1. For Model 2, you have to do something similar. So get first the nth term for the prize money. So A is 1,000, R is 1.1. And now focus on the one that you are actually being asked, which is the value to be donated to charity, which is 5% of this. So obviously, again, this is going to be 50. Now apply the sum of the first n terms, n being 40, for this circumstance, in which A is 50. Just substitute the values, and you have the final money that would be delivered to charity under the second model, and that would be much smaller than the other one, $22,100.